Hi, welcome back. In this video, we're going to talk about solving quadratic inequalities. So in our previous video, we spoke about linear inequalities, and now we're going to focus on quadratics, right? And it'll be a slight variation, but very, very similar concept. Let's get to it. So as you can see here in our first example, our goal is to solve this quadratic inequality. Well, if I treat this as an equal symbol, I'm left with x squared plus 4x plus 3 is equal to 0. And how do we solve a quadratic? Well, we have three methods, right? We have the quadratic formula, we have the square root method, and we have factoring. We're going to go with factoring for this one. And as you can see, we got x times x, 3 times 1. When you cross multiply, they add up to 4x, right? So my factors here are x plus 3 and x plus 1. This allows me to solve for each x value separately. Now I got x plus 3 equals 0 and x plus 1 equals 0. As I move things over to the other side, I get negative 3 and I get negative 1. Now, these would be solutions, right? Or x-intercepts or roots in a quadratic. But here we're dealing with an inequality. So I'm going to draw a line. I'm going to draw a number line with these two values at negative 3 and negative 1. These are what we call our critical values. Because now we're not looking for x equals a particular answer. We're looking for a range of values. And these are my critical values that allow me to determine which range of values I'm going to be focusing on to determine when this statement will be true. Right? So because there's a less than or equal to symbol here, the equal to component makes me want to already do these as circled dots or closed dots. Right? Remember that open circles deal with parentheses and the less than or greater than symbol, and closed circles deal with the brackets and less than or equal to and greater than or equal to symbol when you're dealing with like inequality versus interval notation, right? So I want to know, when is this function less than or equal to 0? Is it numbers less than negative 3, between negative 3 and negative 1, or greater than negative 1? And to do that, I'm going to select three numbers, one in each of these ranges. It doesn't really matter what number you use, so feel free to pick whatever number you prefer. I'm going to put negative 4 in here. I'm going to select negative 2, and then I'm going to select 0. Plugging in 0 or plugging in 1 are very nice numbers that allow you to simplify pretty quickly. So let's plug in negative 4. I'm going to plug it into my original inequality to see if that statement is true in that range. So we got negative 4 squared plus 4 times negative 4 plus 3. Is that less than or equal to 0 is my question. Right? And as I simplify, I get 16 minus 16 plus 3. Is that less than or equal to 0? Well, 0 plus 3 is not less than or equal to 0. I got a positive number, and I was looking for less than 0, so I was hoping for a negative value. So no matter what number I plug in from this range, I'm always going to end up getting a number greater than 0, which does not satisfy my condition. So I'm not going to shade this region. Now I'm going to choose negative 2 in this region. If I repeat the process and I plug in negative 2, is it less than or equal to 0? Right? Is that statement true? Well, negative 2 times negative 2 is positive 4. 4 times negative 2 is negative 8 plus 3. Negative 4 plus 3 gives me negative 1. In this case, we did get a negative value. We were hoping for something less than 0. This will be part of my solution set. I can plug in negative 2.5, negative 1.5, and it'll give me something less than 0. Not negative 1, but something less than 0. Now let's plug in 0 just to confirm. If I check this range of values and I plug it in here, 0 squared plus 4 times 0 plus 3. Is that less than or equal to 0? Well, 0 squared is 0. 4 times 0 is 0 plus 3. Notice how we get something not less than 0. I got a positive value here. So the only part of the quadratic that is less than 0 is this range of values. What does this really mean, right? If I were to graph this quadratic, this is what it would look like. Something like this. With the x-intercepts being at -3, -1, and I'm putting, because of the equal symbol, I'm closing the dots. And this tells me that the function is below 0, right? 0 is right here, the x-axis. The function is below 0 between these two numbers. Everywhere else, it's above 0. That's why everything less than -3 over here to the left, we didn't shade it because it was going to be above the x-axis. Between -3 and -1 was below the x-axis, and then everything above or greater than -1 was going to go back to above the x-axis. This is really another way to look at the interpretation of this inequality in a graphic form, right? Instead of in a linear coordinate line, we can look at a coordinate plane. And this can vary, right? The graph could look like this. We could look at a function where we want to know when is the function less than 0. And maybe this is above the x-axis. This is greater than or equal to 0. And this is where we deal with everything below 0. Or maybe it doesn't cross it at all. And there are no places where the function is below 0. So then there's no solutions. And by no solutions, I mean no real solutions, right? Because then we start getting to imaginary numbers and things like that. All right, let's do another example. I just wanted to go through a thorough explanation here of what it meant for this to be less than or equal to 0. We don't have to graph the function each time. We just have to be able to plug in a value from each one of these three ranges. When you plug it into the original problem, it'll tell you, is it true there, is it true there, or is it true there? And wherever it is true, like here, it'll be true for anything in that range. And that's part of my solution set, right? So I have this solution as a coordinate line, or as a number line. And then I also can write it as interval notation with brackets because it's a closed dot. And I can also say x is less than or equal to -1 while being greater than or equal to -3. These are all different ways of expressing the same solution set. Let's try one last one. All right. So we want to solve this inequality by putting everything on one side, right? It's a quadratic. If we want to factor this and do our three-column method, we want to be able to put everything on one side. So I'm going to move everything at the same time. Subtract the 2x squared, right? This gives me 2x squared. If I add 7x, this gives me 8x. And if I move the 9 over, I get -10. And everything got canceled, so it's greater than 0. I'm already thinking open circle because there's no equal symbol, right? Now, notice how everything here is divisible by 2. You can divide everything by 2 and solve this equation instead. It doesn't matter, right? The columns will work the same. So if I do the columns here, I got 2x times x. Here I got, let's see, 1 times 10. When I cross multiply, I get 2x, I get 10x. In order to get an 8, I got to subtract the 2, which means this has to have been a negative, right, to get there. That's how we can get a 10 minus 2. So my two factors are 2x plus 10 and x minus 1. And I'm solving for x here, right? I'm replacing the inequality with the equal symbol. And as I solve for x, I get 2x equals -10, divide by 2, x equals -5. When I move the 1 over, this gives me x equals 1. So these are my two critical values. right? This is what's going to allow me to determine my solution set. I write the smallest number first, I write the larger number second, and now because there's no equal symbol, I'm going to use open circle here. Now that I have my three ranges, I can now choose numbers here like -6, I can choose something like 0, and like 2. And I can plug in the three numbers into the original inequality, or if you prefer, you can plug it into this inequality. Either one, right? I feel like plugging -6 into all the x's to compare them is a lot more work than we need to do. So I'm going to plug it into this one. It's a little simplified already. It's already combined like terms. I've already simplified it a little bit. So let's plug it into that one. Let's plug in these three terms in here. So we got 2 times -6 squared plus 8 times -6 minus 10. Is that greater than 0? Remember when we're simplifying, we got to do PEMDAS. So parentheses first and then the exponent. So -6 squared is positive 36. So that's 2 times 36 minus 48 minus 10. 2 times 36 is 72. 72 minus 48 minus 10. I don't even need to know the actual answer, right? I just want to know, is this answer greater than 0? And it is, right? I get some positive number. I get 14. But I don't even have to go all the way down. If I already know that the answer is greater than 0, that's what matters. This is a positive part of my solution set. I try this again with 0. Let's plug in 0 into the equation. When I plug in 0, 0 squared is 0 times 2. This gives me 0. 8 times 0 is 0. And now I have, is -10 greater than 0? No. I got a negative value there. I'm looking for greater than 0, right? And then finally, I plug in the 2. 2 squared plus 8 times 2 minus 10. Is that greater than 0? 2 times 2 is 4, times 2 is 8. 8 times 2 is 16. 8 plus 16 is 24. And as you can see here, I also get something greater than 0, right? So since I was interested in all the values greater than 0, I'm looking for the positive values here. I get this range, and I get this range. And now there's two sets in my relationship, right? How do I describe this with, let's say, interval notation? Well, it's going to go everything less than -5. So let's start with inequality notation. If it's everything less than -5, we can say x is less than -5, or x is everything greater than 1. Remember, we want to use the word or here to describe this because a number cannot be less than -5, like say -10. -10 can't be greater than 1. So a number can be less than -5 and greater than 1 at the same time. So we use, it could be in this range of values or in this range of values. Yeah. And then we can also describe this in inequality interval notation. We start at -infinity all the way to -5 with an open parentheses because it's an open circle. The union represents or versus the intersection. And then we start again at 1 to infinity. Right? The upside down one, as we recall from a previous video or earlier in the year, was the intersection, which was in between. So here's my solution set. This tells me that x can be anything less than -5 or greater than 1, and that would result in this equation being greater than 0. What does that look like graphically? Well, if I graph the x-intercepts at -5 and at +1, I have these open circles. The parabola will be pointing this way. Right? When is the function greater than 0? When is it above the x-axis? Well, it's above the x-axis over here and over here. Everything in between is below the x-axis, right? The rest of the graph is pointing above and pointing up. All right, guys, I hope this has helped. Please let me know if you have any questions. Don't forget to like and subscribe, and as always, we'll calculate.